Howdy, AP PreCal, it's Miss Kosh. This is my third attempt to explain this concept, and I keep not doing a good job, so here's hoping third time's a charm because I have other things to do. Okay, what I want to do is I've got this random scenario here on my unit circle. I'm trying it for these ratios not to be unit circle friendly, but I just have this random angle, and then I reflected it into the other quadrants. Okay, so what happens if I want to find this, if this angle, this positive angle is, let's say that this is arc sine of something not unit circle friendly, 2/5. Okay, if this is arc sine of 2/5, then the angle that comes down here would have, okay, you could think of this as being, here's your, this is 2, this is 5, you're finding the angle who has the opposite over the hypotenuse of 2/5, but this angle down here would have a -2 and still a +5. So this angle is going to be arc sine of -2/5. So the angle that comes down from 0 going down to this terminal side, this angle is arc sine of -2/5. It is also the same amount of angle here, but it's now in the negative direction. So you could say that this is also negative arc sine of the +2/5. Okay. You could likewise say, well, this angle coming here is a negative amount. If I turn around and make this negative, then we're positive and we end up here. So this would also be a negative arc sine of, well, what was it that went down this way? -2/5. Okay. The reason I'm doing this, I'll show you in a second. Okay, so let's come, because there were some AP classroom questions, that's why. So let's think about how we could describe the angle that has this as its terminal side. So what we've got is we've got pi, pi would be here, and then we have to subtract away this particular angle. So you could either say pi minus arc sine of this little positive angle, which is arc sine of 2/5, or you could say that this is pi plus this negative angle, so pi plus this negative angle, arc sine of a -2/5. Now keep in mind, arc sine of -2/5 right here has to be between 0, well, arc sine lives between -pi/2 and +pi/2. So if you take the arc sine of this right here, you're going to get a negative value that's relatively close to 0. It's going to be smaller than, it's going to be more negative, it's going to be between 0 and pi/2, which is about like -1.57. So your radian measure is going to be somewhere between 0 and this -1.57. Okay, so if we want to get this positive angle, let's pick pink. If I want to get this positive angle that goes all the way to here, then I can either, for an exact value, say that it's pi minus this angle, because these are equivalent, or I can say it's pi plus this negative angle, which plus a negative is the same thing as minus a positive. Okay, so there's two ways that we can describe this angle here. Now let's look at how can I describe, you know what, there's too much going on. Let's get rid of some of this. Okay, now let's talk about how do I describe the angle that's got initial side here and it's a terminal side there. So if it comes all the way around, well, we could think of this as pi plus this angle, which is equivalent to that angle. So we could say that this is pi plus arc sine of 2/5. Okay, you guys, this is taking me a little while to think through it and to conceptualize, like, what in the world are they talking about? So struggle with this a little bit. It's kind of confusing. The other thing, okay, so let's give another name for, let's give another name, let's get rid of some of this mess. Okay, we're just going to get rid of a lot of it, sorry. Okay. Let's give another name for this angle right here. So we knew that this part right here was arc sine of -2/5. So now if I want to describe going in the positive direction, well, I don't know how I get that. I can say, well, it's 2 pi plus this negative angle will back me up. And so this angle could also be arc sine negative 2/5 plus 2 pi. Now, if I want additional ones, if I want all of the ones that I might come up with, I could say k and then use that k is an element of the integers. Okay, so now let's think for just a second before I continue. Let's think in terms of cosine. Arc cosine lives between 0 and pi. So if I were to take arc cosine, there it is, two c's next to each other mess me up. And let's do the same, negative 2/5. Now, or let's change this up. Let's just say negative 4/5. I don't know. Now what we're doing, that's not unit circle friendly, but this angle is going to be an obtuse angle that puts me in quadrant 2. If I want the corresponding angle in quadrant 1, that would be this little angle, and this is going to be arc cosine of 4/5. Okay, and so if I want this angle over here, I could say pi plus the one that got me to this point, which would be arc cosine of negative 4/5, or I could say it's 2 pi minus this little one right here. Now you can't see what I'm doing. It's 2 pi minus this angle, 2 pi minus arc cosine of 4/5. Okay, these are confusing. Let's come back. Let me show you why I care about this. So this one question says, we've got this 5 plus 7 cosine x equals 0. For what answer does f of x equal 0? So I have cosine of x is equal to negative 5/7. And so x equals arc cosine of negative 5/7. But arc cosine of negative 5/7 has to live in quadrant 2. That's this angle. But they're saying, no, we want to go from pi to 2 pi. We want to be somewhere over here. So we need this angle instead. So we can think of this as, let's see. Arc cosine of, this one's not good because it's the wrong quadrant. This one, pi plus that, means that we're going to end up over here, which is not what we want either. So that's no good. So we're going to get rid of that one. And then, oh wait, I lied to you. This arc cosine of a positive 5/7 puts me over here in quadrant 1. And so if I'm in quadrant 1 and add pi, this is probably the correct answer. Let's keep going and check the others. The next one, part C, was the one that I was just drawing. We had this angle here, and then we added pi, and we ended up in quadrant 4. So that's no good. And then we say, oh my, okay, let's try this again. Then we say 2 pi, which puts me here, minus arc cosine of 5/7. Arc cosine of 5/7 would be this little angle. And so when I subtract that amount, I end up here in quadrant 4, which is not the answer I want in quadrant 3. So another way to think about this is that we've got the graph. We're going to go as high as, we would have gone from negative 1 to 1, but then we stretch it. We go from negative 7 to 7, but now we go up 5. So it's 12 to negative 2. So here's negative 2. I lied. I don't know why I'm putting it out there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have this point, and then we're 5, 1, 2, 3, 4, 5. We're about here. We're down here. We're back here. We're back here. This is the curve-ish. I haven't talked about. Okay, and then my period here is this. This is 2 pi. This right here is pi. They're saying in this interval from pi, let's switch colors, from pi to 2 pi, that's where they want an answer. We want to know, when do we equal 0? Well, so from pi to 2 pi, where do we equal 0? It's this one right here, which is going to be something, this was the point, 3 pi over 2, comma, what did we scoot up? We scooted up 5. Okay, so we want an answer that's between pi and 3 pi over 2. So we do need an answer that lives in this quadrant right here. And so that is our best answer. Oh my goodness, you guys, these are tricky. Let's see if I can do this last one. Oh, get rid of all this stuff. You get to watch me do all the messiness. Go away. Okay, so this one, let's see if this one's any easier. They tell us tangent of x, we want to know when it equals 3. So this is x would be equal to arc tan of 3. Now, the inverse of tangent lives in quadrants 1 in the positive direction and 4 in the negative direction. Arctangent of 3, it's got a positive slope. It's going to look something like this. So then they say, what are the solutions? Well, it's going to be arctangent of 3 for sure, but then if we have, here's another way to think about this one. If I'm looking at graphing tangent, I've got, this is tangent. There's infinitely many of these guys, and I want to know when they equal 3. So here comes 3. So there's 1, 2, 3, 4, 5, and the ones that I drew, but point being there's infinitely many solutions. And how far apart are they? Well, they are 1 period apart from each other. Okay, so how many answers are we going to have? We're going to have infinitely many solutions. It's arctan 3 plus the period apart, which ends up giving us D. Let me make sure I agree. This says there's only 2 answers, which there are more than 2 answers. This one, the next one here, arctan of 3 plus pi, that's going to be a really crazy thing. That's saying your slope is 6.14, which is even steeper, which is not a thing. I mean, it is a thing, but that doesn't make any sense in terms of the problem. And this is adding twice the period, which is no good. So the answer we want is D. Hopefully that was helpful. Let me know if you have any questions. Good luck.